Cool. Okay. So now the second boundary we'll start looking at is for the decision tree, right? Okay. So in decision trees, if you recall, the questions that we were asking to purify our data set was in the form of a feature comma threshold pair. So we have all these bunch of possible questions, and later we choose a question based on some heuristic, such as there are various measures of purity you can choose from, such as the Gini index or the entropy. Somehow we'll select a question that kind of makes the leaves pure, so that they have a greater number of elements belonging to one class than the other, so which should have also been discussed in the previous lectures, and therefore since we are only considering a feature comma threshold pair, the decision boundary will actually take an interesting shape, which I will illustrate over here. So suppose my question, so one possible question that I could ask was, is age less than 20? This is one possible question. The second one would be, is salary greater than say 30,000, right? So these are the possible questions I can ask, and now think for a moment how these would look on a graph, right? So before I draw, I hope you would have come up with the answer. So suppose this is age, suppose this is 20 on the axis, and suppose this is salary, the salary axis, then this is 30,000, right? And now here age being less than 20, I'll maybe mark this as red, would correspond to me doing a split like this and then saying is age less than 20. So that would correspond to this kind of direction. So if I say yes to the age less than 20 question, then then that means that my point is somewhere along this. Suppose I have another question that says salary greater than 30,000. I'll mark this with green. Then I put another split over here and then see that my salary greater than 30,000 implies the regions above. Now for example, if a test point that comes into my model satisfies that age is less than 20 and salary is greater than 30,000, then it better lie in this particular region, right, where both my constraints are solved, right? So we have this, and now I would like you to pause and think about one kind of a limitation of this particular approach. I hope you thought about some of them. The answer is that using this particular approach, there is no way we can get a line that goes, say like this, if it is above this line or below this line, because this actually corresponds to a linear combination of both your points. So suppose it's some x times salary plus y times age. Okay, these can be anything. I will not use x and y. Say a and a times salary plus b times age is, I don't know, greater than c or less than c or so on. Only if it's a linear combination will you start to think about lines that are not at least here horizontal and vertical. So that is something important about decision trees. All the questions that you're asking will make splits that are parallel to your axis, or so to any axis. So it is only axis parallel splits, and you cannot have diagonal lines as such in a decision tree, right? So now we'll illustrate for one example how this looks like. So perhaps I'll yeah. So I say I have this. Say there are some points here. Yes, and I also have some points here. right? Yeah, so I have some points like this, and then let's say I have some points like this also. So these are two different classes, right? So now here, if I were to plot, if I were to use a decision tree, a good decision tree would say find these separating hyperplanes or separating lines. Yeah, and these are possible in an decision tree because we just talked about it being vertical so that it will work. Sometimes in the overfitting scenario, say sometimes say I perhaps have an outlier here, what my decision tree will try to do is like we know it's an outlier, it doesn't really convey that much structure about the data also. There's nothing special about this point except for the fact that it's most likely mislabeled. But what my decision tree, which is aspiring to get 100% accuracy, will also make these other splits. So it will split here, it will also split here, it will also perhaps split here, and I think that's enough splits because in this particular region we only have 1 point. So it has asked 3 additional layers of questions to really figure out this point. But on the hindsight, perhaps it was not necessary for this at all. Now, decision trees are very popular in machine learning simply because they give you these nice tree-like structures where at every level you know what questions your tree is asking. So it becomes a very interpretable story that you can put on your data set. But these kind of questions do not really add much value to this interpretation. In fact, they make your interpretation more complicated. So which is why we have discussed certain strategies. One is to constrain the depth of the tree. So in constraining the depth of the tree, we say you can only ask some n number of questions before you predict, right? So we will not allow you to ask more questions than that. So for example, in this case, for me, I could set my depth to be 2, right? So I can say if it is on the right of this and if it is on the top of this line, then I will predict that. So those questions are enough. So if for a point over here, I can say if it's below this line, okay, so first I'll have to start from here. If it is left of this line and if it is below and also if it is left, okay, so this is in this case at least it is 3 of them, not considering these particular lines. But if I were to also consider these lines, if I did not, then my depth would actually be plus this particular question, then 5 and 6. If I do not constrain the depth of my tree, then I will actually have a depth of 6 only because of this one particular point, ensuring it is the tree is interpretable. Another possible way you can think about is the proportion after you split the leaves. So for example, now that you so if you initially say have a data set with 50% of positive entries and 50% of negative entries, and say you make one split and then later get a data set with say 80% of positive entries and just 20% of negatives, then if I can perhaps say okay, that's good enough, don't bother trying more about it, which is also another strategy you can use to reduce the depth of the decision tree, thereby making it much more robust to outliers, one, and secondly also interpretable in the analysis scenario. So right, so now we have these let's also emulate this example in orange.